the quadratic function and the absolute function. That is the two type of a non-linear function that we have discussed. So when we say nonlinear function, that is a type of function wherein when you graph this function, it will not be a straight line. So nonlinear function are not straight lines when they are graphed. It cannot be written in a form of y equals to mx plus b. One of that example of nonlinear function is our quadratic function, wherein when we graph the quadratic function, the result or the shape of that graph is what we call the parabola, which in the U-shaped curve of our quadratic function. We have discussed on how to find the input and the output for our quadratic function, wherein we substitute the value of the given set of x to our function that we have, wherein you also identify its coordinate once you are done solving for its output using the chart that we have discussed, which is this one. You still remember? You have an activity with this one wherein you solve for the input and you write down the coordinate for us to be able to graph our set of function. For example, we're going to solve one input to determine the output and the coordinates that we have for this function. Our function is y equals to x squared. If one of the value of x or one of the input that we have is negative 3, so substitute the given value of your x in the function y equals to x squared. So you have y equals to negative 3 squared, and the output or the value of y that we're going to have is equal to positive 9. And the coordinate of our function is negative 3 and positive 9. That's how we solve for the output and the coordinate of our nonlinear function. So we're not going to solve all the value of input that we have here, since it's just a review. So we only substitute the value of x to the given function that we have. So to determine the direction of the parabola once we graph our linear or our quadratic function, if we have a positive, we have a positive exponent to the leading term of our quadratic function, the graph will open upward. If you have a negative leading coefficient for your function, the graph will open downward. That's once. That is how we're going to identify the direction of our parabola. If you have a positive coefficient in your variable x or in the first term of your function, it will open upward. And if you have negative, it will open downward. So that is about quadratic function. Let's proceed with the second type of nonlinear function that we have, which is what we call the absolute function. Absolute value function, when we graph this type of function, the shape of its graph is letter B. The same with your quadratic function. If you have a positive absolute value, the graph will open upwards. And if you have a negative absolute value, the graph will open downward. So the same with quadratic function, for us to be able to graph our absolute value function, we need to solve for our output and to determine the coordinates of our absolute value function. For example, using this function that we have, which is y equals to the absolute value of x. So, for example, we have this chart. So the same, substitute the value of your input or the variable x to the function that we have, which is y, equals to the absolute value of x to determine your value for y and its coordinate. So you have y equals the absolute value, which is negative 2. So y is equal to positive 2. So our coordinate is negative 2 and positive 2. So that's how we solve for the input and the coordinates of our nonlinear function. Okay na tayo with the nonlinear function, quadratic function, and the absolute value function? Okay. So let's proceed with identifying the number of solutions that we're going to have to our simultaneous function. So let's proceed with simultaneous linear equation or function. So for simultaneous function, it involves two types of function or two set of function that we have. So we can only say or to determine how many number of solution we're going to have for the two set of linear function, we need to solve for its value of x and y, or looking at the value of your slope and your y-intercept. So, simultaneous linear equation, the process in finding the answer to determine how many solutions we can have for simultaneous linear equation is by graphing. We have three methods for us to be able to solve or to determine how many solutions that function has. We have for graphing, the substitution, and the elimination. That is the three ways of solving simultaneous equation to determine the number of its solution. So for example, we have this equation and we're going to find the solution to determine the number of its solution we'll be having for the equation 2x plus y equals negative 2, 2x plus y equals 3. So we have three ways we can solve for its by graphing, by substitution, or by elimination. So let's solve using the form of equation which is the slope-intercept form. Slope-intercept form is y equals to mx plus b, wherein your m stands for the slope and b stands for our y-intercept. So looking or rewriting from standard function into slope-intercept form, we can determine the number of solutions that we're going to have from the set of functions that we have. We have three types of solution. The one solution, the two solution, no solution, or the infinite solution. That is the three types of solution we can have for simultaneous equation. The one solution, the no solution, and the infinite solution. So let's determine in this example that we have. Let's rewrite this equation, the two equation that we have into slope-intercept form. Let's start with the 2x plus y equals to negative 2. So if we're going to change this standard form into slope-intercept form, transpose positive 2x to the other side of the equation. So we will be having y equals to negative 2x minus 2. So this is the slope-intercept form of the first equation. Let's transpose the second equation that we have, which is 2x plus y equals to 3. The same process, transpose your term with a variable x, so you will be having y equals to negative 2x plus 3. Looking at the equation now, since we have written it in the slope-intercept form, we can now identify its slope and its y-intercept to determine how many solutions we can have for this simultaneous function. The slope for the first equation, we have negative 2, and the y-intercept is negative 2. For the second equation, our slope is negative 2, and our y-intercept is positive 3. Looking at the set of slope and y-intercept that we have, what is the identification if you have the same slope but different y-intercept? How many solutions we're going to have? We will not be, we will be having a no solution. So that means if you have the same slope but different y-intercept, you will be having a no solution. So if we're going to graph a no solution simultaneous equation, what will be the graph of this equation? Parallel. The graph of these two equations will be parallel. Since it doesn't have a solution, so the graph of its equation is parallel to each other. Okay? So that is for simultaneous with a no solution equation. Let's have another example for a simultaneous function. Can I clear the screen? Okay. For example, we have this equation, which is x plus y equals to 5, and we have 2x minus y equals 4. So let's transpose this equation from standard into y to slope-intercept form. So let's start with x plus y. So if we're going to transpose variable x to the other side of the equation, the slope-intercept form of x plus y equals 5 is y equals to negative x plus 5. That is the slope-intercept form of our first equation. Slope-intercept form of the second equation is negative y equals to negative 2x plus 4. Since we don't have negative sign, we should not have a negative sign in your variable y, so we're going to divide both sides by negative 1. So the slope-intercept form of our second equation is y equals to 2x minus 4. So we are done changing from standard into slope-intercept form. We can now identify the slope of each equation and its y-intercept. The slope for our first equation is negative 1. The y-intercept is positive 5. And for the slope and y-intercept for the second equation, we have positive 2. And for y-intercept, we have negative 4. Looking at the slope and the y-intercept, we have different slope and different y-intercept. So looking at those things, how many solutions we're going to have? If we have different slope and different y-intercept, we're going to have a one solution. So if you have different slope and different y-intercept, the number of solution that you're going to have for a simultaneous function is one solution. And if we're going to graph these two equations that we have, this line or these two equations will intersect to each other. So you have an intersection point or an intersecting line as the graph of our linear or simultaneous function. Since you have one solution and the intersection point of the two graphs is the solution of our simultaneous function. Okay? So another example for the simultaneous function. For example, we have 4x minus 2y equals 6. 2x minus y equals 3. So let's rewrite this equation into slope-intercept form. So we will be having negative 2y equals to negative 4x plus 6. Divide both sides by negative 2. So the slope-intercept form of the equation is y equals to positive 2x minus 3. Okay. Slope-intercept form of our second equation, we have negative y equals to negative 2x plus 3. Divide both sides by negative 1. So we have y equals to 2x minus 3. So that we have now the slope for the first equation is positive 2 and the y-intercept is negative 3. The same with the second equation. Our slope is positive 2 and y-intercept is negative 3. So looking at the slope and the y-intercept, we have the same looking at the slope and the y-intercept, we have the same value for our slope and the y-intercept. So how many solutions we are going to have based from the slope and the y-intercept?
Many.
Many solutions. So if you have same slope and same intercept, you will be having a many solution. So if we're going to graph the simultaneous function that we have, the graph of it, what will be the graph of these two functions? If no solution, yes, Chloe? Anong graph? Yeah. There will be only one graph, or the two lines of these two functions will collide to each other. So for no solution, the graph is parallel. For one solution, the graph is intersecting line. For many solution, the graph is one line only. Means the two function is colliding with each other. So that is the simultaneous function. Okay na with the simultaneous. Yes, Gabby? What? So we can proceed with the
Yep.
maximum. I thought you have something to say. Okay, so let's proceed with the other topic that we have discussed. So we're done with the non-linear function and the simultaneous function.